Hi all, I am VINOD K, lecturer in electronics, EKNM Government Polytechnic College, Trikadipur. Today we are going to learn about the basics of transistors, that is bipolar junction transistors. As we know, transistors are basically classified into two types, that is BJT, bipolar junction transistors, and FET, that is field effect transistors. In this class, we are concentrating only on the basics of bipolar junction transistors. As you all aware of, the objective of today's class is the physical structure of the BJT, working principle of PNP and NPN transistor, and the mechanism of current flow in it, and different transistor configuration and transistor equations. And as you all know, these are all different types of transistors as you can see in the laboratory, or if you open any circuit board you can see this type of transistors. So as I told you, there are three terminals for a transistors. They are emitter, base, collector. As you can see here, you can see emitter, base and collector of a transistor. On the right side you can see the symbol. Emitter always has a arrow mark. Okay, here is the symbol. There are two types of transistors, BJT. There are two types of BJT. One is NPN and other one is PNP. In case of PNP, that is in the left side, you can see that the arrow mark of the emitter is inwards. It's inwards, and for NPN transistor the arrow mark is outwards. See, emitter always has an arrow mark. Okay, and there is always a circle, as like all active components have a circle. Okay. Now regarding the physical structure of BJT, base is in the center, the emitter and collector are its two sides. We have got emitter, base and collector. Base is in the center, and regarding this, emitter is heavily doped, base is very less doped, collector is also heavily doped, but among these the most heavily doped is emitter and the least heavily doped is base. So the doping concentration at the base section is very less. And regarding the size, emitter region is large size, base is very small in size, and collector is also very large, a little more larger than emitter, a little bit larger than emitter. Okay. Now the physical structure of two types of transistor, that is PNP and NPN. You can see that in PNP transistor, emitter is P, base is N and collector is P. You can see the difference in the size. Base is very narrow, and there are two junctions for a transistor. One junction is emitter base junction, that is just like a PN junction diode, and the other junction is collector base junction. There is a depletion region. There will be a depletion region whenever N and P material come together, as we have studied already in PN junction diodes. And this one junction is emitter junction and the second junction is collector junction. Emitter junction means emitter base junction and collector junction means collector base junction. On the right side we can see NPN transistor where emitter is N, base is P and collector is N. What this N, P, N, all this means? This means that this is N material and other one is P material, like that. What is N material? In N material the majority carriers are electrons, and in P materials the majority carriers are holes. How these majority carriers are created, that all we studied in the last section, that is by doping. One intrinsic semiconductor can be converted to extrinsic semiconductor by the dop process called doping. When we add pentavalent impurity you will get N type. When we add trivalent impurity you will get P type. Okay. So in NPN junction transistor, it's a single P-type semiconductor layer is just sandwiched between two N-type semiconductor layers, just like a sandwich. and for PNP it's just reverse. N-type semiconductor is sandwiched between two P-type semiconductor layer. Okay. And as far as the emitter is concerned, it emits the charge carriers. It supplies the charge carriers. It emits the majority carriers, I should say. And it is heavily doped so that it can inject large number of charge carriers into the base that we will study later. And size of the emitter is always greater than base. We have already discussed these things. And as far as base is concerned, base is middle layer of BJT which is thin compared to emitter and collector, and base is very lightly doped. And for collector, it collects the charge carriers. Whatever the current comes towards it, it collects. So the size of the collector is little bit larger. It's doped between emitter and base. So doping concentration is higher than base, but little bit smaller than collector, and is moderately doped. But it is always greater than emitter and base in size. Okay. Now we can go for the working principle of NPN transistor. A transistor can be classified into different configurations. Here I am dealing with the common base configuration. As far as the working principle is concerned, as I told you, there are two junctions. One is emitter base junction and the other one is collector base junction. And applying two voltage towards it. For the emitter base junction, I am making it forward bias. See, this is NPN transistor. How can I make emitter and base junction forward bias? I will be connected N to the negative of the battery and P to the negative of positive of the battery. I have two batteries here. One is VEB and the other one is VCB. The name EB came from EB junction, that is emitter base junction, and CB came from collector base junction. So VEB is the voltage that we are connecting to the emitter base junction, and VCB is the voltage or the battery that we are connecting to the collector base junction, which is bigger than VEB. So VEB forward bias the emitter base junction, whereas VCB reverse bias the collector base junction. You can see VCB reverse biased because the collector, that is N, and the battery VCB is positive. So N negative is connected, N is connected to the positive, and base P is connected to the negative, that is reverse biased. Whereas VB is forward biased. What happens when emitter base junction is forward biased, and what happens when collector base junction is reverse biased? As we know, in PN junction diode, when it is forward biased, the majority carriers will flow towards it. So here the majority carriers in the N region, that is in the emitter region, that is electrons. Electrons will move towards the base because the negative of the battery will repel those electrons. So electrons will break the depletion region between the emitter base junction and it will flow towards the base. As far as base is concerned, the doping concentration is very low and it is very thin in nature. So what happens? The electrons reaching the base will recombine with some holes there, and most of them will move towards the collector because in the collector it is reverse biased. That is, there is a positive voltage that attracts the incoming electrons from the base. Okay, there is a positive voltage given to the collector which will attract the incoming voltage coming from the emitter through the base. So in effect, finally what happens is most of the majority carriers that coming from the emitter will reach the collector, and very small number of carriers, here carriers are electrons, very small number of carriers will recombine in the base, and the flow of electrons here denoted as currents. Here we have emitter current IE and base current IB and collector current IC. Emitter current is given to IB and IC. So IE is equal to IC plus IB as far as Kirchhoff law is concerned. Kirchhoff current law. IC and IB are coming from IE, emitter current only. So emitter current is distributed into two currents, that is IC and IB. but IB is very less. Okay, 2 or 1% compared to IC. So I is equal to IC and IC plus IB, where IB is very negligibly very small because base region is lightly doped, also it is very thin. Okay, this equation is always true in any case, whatever be the transistor configuration or whichever be the transistor NPN or PNP, whatever it be, IE is always equal to IC plus IB. That is, emitter current is always equal to collector current plus base current. Remember, collector is the region which collects the majority carriers. Emitter is the region which emits the majority carriers. Now we have three types of transistor configuration, that is common base configuration, common emitter configuration and common collector configuration. Let us see the difference between these three. Here we can see these three configurations. Common base configuration, CB mode, you say CB mode. CE mode, that is common emitter configuration. CC mode, that is common collector configuration. Let us see into it. What is common base configuration? Here we have got just before I told you the connection between the input and output. That is, the base is common to input section and output section. I have taken emitter as the input and collector as the output, and base is common to both of them. So what happens? It becomes common base configuration. I am applying an input signal to the emitter. Here we can see it is an NPN transistor. I am connecting an input signal to the emitter. I am taking the output from the collector. The current I is equal to IB plus IC, but here the current direction is in the direction of Hall's flow. In electronics, always the current direction is in the direction of the Hall's flow, Hall's direction. So base is common to emitter, input and output. That is why this configuration is called common base configuration. So in common base configuration, input is IE and output current is IC. Output is taken across the base and collector, and input is applied across the base and emitter. Okay. Now just common emitter configuration. You redefined it. Here input is given to the base and output is taken across the collector. So what happens? Emitter is common to both the input and output. Here we can see in the picture, we can see emitter is common to, emitter is grounded. Here base is common, here emitter is common. So it is common emitter configuration. Input is given to the base and output is taken across the collector and emitter. Input current is IB and output current is IC. Here also the current equation is always the same, I is equal to IC plus IB. There is no difference in that. You can see the arrow mark of the current. Okay. Another case, third one, common collector configuration. From the word name itself, it means that the collector is common to both input and output. But whether we are giving input to the emitter or to the collector, that is a question, or the base, that is a question. Here we are giving the input to the base and output is taken across the emitter and collector. Output is taken across the emitter and collector. Collector is common to input and output. These three are the configuration of the transistor, that is common base configuration, common emitter configuration and common collector configuration. And in all these cases, this transistor equation is true. So that's all about the basics of transistors for now. Thank you.